Hello everyone and welcome to the Game Engine programming series where we write the game engine from scratch. In the last video we managed to host a native Win32 window in the level editor, which is a .NET Core application. Because we are doing this to render graphics, we need to update the dimensions of the hosted window whenever it's resized. Today we are going to look at how we can receive Windows messages in the .NET side so we can get notified when the user does something that results in resizing the render surface. So one more thing that we have to do, and that's a bit tricky, is to handle resizing this window. Because if you remember how the resizing and update of the internal structure of the window implementation was handled, it was by using the window proc. So every time the window was resized, that window proc was called. But if I now place a breakpoint in our internal window proc where this resizing is handled, you can see that this now never happens. So when I resize this, those breakpoints don't trigger. And that doesn't mean that this function is not called, it is. So as you can see, if I set a breakpoint in the start outside this switch, then you can see that this function is called, of course. But these messages are not sent, except this one, the WM size is called, but we don't want to resize our window this way because this message is sent a dozen times each frame, right? So we don't want to handle our resize this way. It's an inefficient way of resizing the window. So for example, if I would resize the main window like this, then this message is sent. And fortunately, there is something to do about this, and that's by having our own window proc in the .NET side as well. Here you can see that we have this Win32 window hosted in our WPF application, but because we are on Windows operating system, even this WPF window has a message loop, and therefore we can use a window proc to receive messages from the message loop of whatever window this window is hosted in. And we can combine these two to handle resizing. So going back here in the render surface view, after creating this host, we can attach a message hook to it. Using this hWindow source hook, we can attach a method to the message loop for the hosted window. And we don't have this method yet, so let's generate it. And as you can see, it has almost exactly the same parameters as one of those window procedures, except it has got one more that indicates whenever we want to let the window know that we handled that message or not. So you have a chain of these window procedures, and whenever we set this handled to true, then it won't get to the other window procedures. And what I would like to do is to do the same as we did here. And now the thing is that we don't have these defines in the C# side of things. So we will have to copy these values in an enumeration and use it that way. And luckily, there aren't a lot of these values that we have to copy. So we will need size. And we also need to know whenever we enter sizing or moving the window. And for that, we have enter size move and exit size move. So we need these two both. And we also need to know when the window is sizing. And these are the only message types that we need to process right now in order to be able to handle resizing these hosted windows. Now, the thing is that because we don't have a border for our hosted windows, that window can't know if it's resizing or it has entered resize or move or any of these three, but it can know when its size has changed. So the only message that is received after a resize is this one. So we can just ignore these. And then handle resizing here. And we would like to handle resizing for two reasons. First, because we are not handling the resizing here, the internal data of this window aren't going to be updated when the window is resized. So we somehow need to make sure that this client area is updated whenever the hosted window is resized. And the second reason is that we also want to resize the graphics surface on which we are going to render, because that's a separate thing from the windows. So whenever the window is resized, we also need to resize our renderer. And here in this render surface view, we are going to call a method that will handle those kind of things. So first in render surface host, we'll have a new method for resizing. And for now, I'll just look a message. And now I could just call host resize. And we also need to return an int pointer, which is just a 0 pointer, because we are not doing anything special here. And now you can see that whenever this window is created, this resize is called. And if I resize this area by dragging one of these grid splitters, you can see that the resize function is called a lot of times. That's not good. We want to just handle resizing once we let go of the mouse button. To prevent repeatedly resizing the render surface, I'm going to write a class that I'll call a delay event timer. And as the name indicates, the idea behind it is to wait a certain amount of time before actually calling an event handler for an event. If the event is raised again within this time interval, it will be ignored and we reset the timer. If there haven't been any events after this time interval, then the event handler is called. These are the arguments that we want to give to the event handler. And the most important one is whether we want to repeat this event or not. So if the event handler will handle that function call, then it will set this repeat event to false. And if it wants to be called again after this delay, then it will request a repeat event by setting this repeat event to true. And we also can give some data over from the caller to the function that's called, because we are not directly calling that function. So sometimes what we normally will give to the called function by parameters, we can do that now by using this data. Okay, this is all there is to it. When we create a delay event timer, we can give it a delay. So it will wait before calling the function that we wanted to call. And here we create a dispatcher timer for that will call on timer tick using this interval. And I am taking half of this amount because we don't want to wait twice as much because we just missed this delay. So if you have a delay of 1 second and this timer tick is just before 1 second has passed, then this function wouldn't be called and we have to wait 1 extra second. And that's not what we want. So I'm taking the interval of this dispatcher timer to be half of our delay. So we are certain to be called around that delay time. So we have this dispatcher timer and it will call this on timer tick every half delay time. And here we check if the delay time, which is the time now minus the time that the trigger was called. If that's less than the delay time, we just return. We don't have to do anything. But if the delay time has been long enough, then we can call the function that we wanted to call in the first place with these event arguments and this data, which is, by the way, optional. We can just pass nothing and it will take null. And if the event handler that we just called set this repeat event to true, that means that timer is still enabled and we are going to tick again and therefore call that event handler again. But if the event handler set this repeat event to false, then this whole timer is disabled and we stop calling it. And this way we can now change our render surface host to not call this resize right away, but just wait a little and see if we call it again. And after some time that we didn't call this resize, the actual resize will be called. Here where we create this resize timer, we tell it to check every 250 milliseconds or a quarter of a second. And if after this amount of time we didn't call that function again, it will call the function for us and the resize will happen. And if we called the resize function within this amount of time, then the last event time will be reset and the function won't be called. This is our event handler, and the actual resizing will happen here. So whenever we call the public method resize, we just trigger the resize timer. And here, in this private method, we can handle the actual resize. And here we can set our condition for handling resize, actually. So while the left mouse button is down, that means that we are still dragging and we don't resize. We just tell the resize timer to call us later again. And then we can check if the left mouse button is down. And if that's not the case, then we can do the resize. Now let's see what happens when we resize the hosted window. So when we drag, nothing happens. As long as I hold the mouse button down, nothing happens, but when I let go, the window is resized. That works fine. But when we resize the main window where this window is hosted, you can see if I clear these, you can see that if I resize it like this, even though I'm holding the mouse button, it still resizes. And that's not what we want. I want to just not resize until I'm done resizing. So this might be good enough for you. I mean, it's a question of how strict you want to be with regard to resizing. Because it works, the window is resized whenever we maximize, minimize, or resize the window. But if you really want to prevent this from happening, so that when you resize and you stop resizing, but you're still holding the mouse button down, it keeps resizing. That's because for the window where this render surface host is located, this mouse left button down isn't really registered here in this event handler. So for example, if I do a breakpoint here and I start resizing, then you can see that this left button is released, but I was holding it down. And for some reason, it's saying that it's released. And if you really want to prevent this resizing, there are also some things that we can do about it. For example, by having another message filter for the main window, so we also receive resized messages when the main window is resized. I'm going to show you how to do that in the next video, where we also finish the subject of hosting native windows. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!